I found out last place. It's like I'm trying to see who's talking. I'm like I can't make that a face out. You know that's key. It's not it's not very big, so it's kind of hard unless they when they zoom in. Oh yeah, that's great.
I can't tell who's speaking, but I can see who's raising hand.
Right, I can see that.
Yeah.
I'm beginning to make out, a couple of the profile images, so I can kind of identify who. Like so that's Chloe. That's now some of the other girls, I'm still not sure. Like a lot of them are dark haired. I'm like, I can tell which one's.
Those two, not Sammy, but the other two sit side by side. You're being almost country because I don't know which one's which.
And speaking of that, we need to know.
Good morning.
Good morning.
She's not like a template.
Do I need to take her out of the course canoe?
If you want to, sure, I'll do that, but if you would not.
Well, I
You'll do it while you're sitting here.
Well, I still don't have secure connection.
Oh, never mind.
So breathe her. Just go ahead and of course just suspend her.
Yeah.
And then also Courtney dropped the 4 sentences.
Yeah. That was kind of. I guess Emily moved over.
Wait, that should be an 82 on the bottom of that. Okay. Sydney.
Amanda, you there?
Yes. I'm handing back tests to people that walk in.
I'm sorry, I can't really hear you.
Try again.
I'm handing back tests to people that are coming in.
Yeah, that'd be fine. Go right ahead. Amanda, you also could, for future tests, ask them to make sure they write pretty dark. If pencil won't work, maybe use pen. I'm not a fan of pen for math. That work. Also, a couple of them put their name like on each page, which was helpful too. It's great. So because I didn't want to staple it, so I had to scan it back. So, but there was 3 or 4 that it's real hard to read. It's like I was kind of, that's probably about right. So make sure they know to write it right on. So.
Okay.
How well did it come back? Like when I printed it, some of those were really light, so I'm guessing when it scanned back, it's light. Like, look at phrases. This should be really light.
I mean, overall, Rezo's is a little light.
We'll get,
but I have his original. You want me to give him his original that you didn't grade?
Yeah, you can give him back the original. That's fine.
Are you sure?
Yeah, I think. Well, tell me why you're hesitant, but what's your thought on it?
Well, I mean, that's fine. As long, it doesn't have any marks on it or anything, so they can at least read it.
Right, and I'm going to keep the scan. Yeah, they can at least read it better. And I'm going to keep the scan copy.
Yeah, that'll work.
So I'll know what I mark on that. So
yeah, I'll just give them back their original one.
If you can original and the graded copy, that'd be fine.
So it's not gonna happen.
Okay, I was about to say.
Miles and I got into a little heated discussion yesterday.
Because I got an email yesterday saying that we're doing service stuff, which is really confusing because it says that it starts at 9:30, but it's also picture day
at 10.
Yeah, and for senior retakes, because I look terrible in mine. So I'm gonna get a retake. I mean, it's not gonna look any better, but it might, so I'm gonna try.
Yeah, so I've canceled it till next Friday. Yes. Here's your originals to do, in case you have trouble reading anything.
Disclaimer. If we got extra credit for the discussion points, is that included in this grade or no?
From what I understand, when he was talking about the syllabus, it's like a big pot of points.
Yeah, and they had added that. Like at the end of the semester?
Yeah, and like probably in the isothermal Moodle, he probably has your updated grade, and you can just check that. What is next Friday? The 8th. Yeah, apparently Miles was just like, you just have to have it on Fridays when we don't have Phoenix Fridays. And I was like, well, do you want me to start clubs or not? I don't have to. It got heated.
Oh. That looks perfect.
Josh.
Um,
I don't know, do you? That is your original and then the one that he graded.
And then for this one, the first part of the day was like, that it's not definition. No.
Yeah.
Divided.
Yeah.
The biggest snow. Yeah.
I was already. I was thinking.
So.
Outside, outside,
You're the right.
go,
Did my son. What? Okay. Okay. Oh no, he's also three. Or whatever part. Not just your little. Yeah, I know. Actually, I don't understand anything you're saying. I tried. It did not work out. But how much paraphrasing did you do? Did you do like line by line or just? Yes. You did?
Oh, I'll separate it, something else. Oh, yeah, yeah.
It's weird.
Whatever. She don't count it. I'm stuck.
But back to the book, it says true.
Coupé-ish. I think something that's a compliment.
I don't have any real, else kind of real. Which one are you talking about? Oh, we got a couple of last days.
Numbers.
Highest? By any chance? Just had to feel nice about itself. This is the 7th grade scale. So this is a C. Right? This is a C. Because it's 93 to 185 to 93. That's what I'm saying.
It says true.
I had questions.
Yeah, I don't think this is going to be a transfer credit.
Just clear it. I don't even teach this class.
Okay. This one, what did you do wrong? Because if you take this
Because
out.
the inverse sign is only in the domain of
Yeah, but
negative pi over 2 to pi over 2.
Darn.
So it would be negative pi over 4. I forgot the domains. Yeah.
So,
The inverse sign is only in the domain of negative pi over 2 to pi over 2.
Also C. Or
So
not
this,
letter
so
C.
this inverse sign would be negative pi over 4.
Why didn't we think of this? I don't know. So the
We
answer
were
is
too
pi over
stressed.
4?
Negative pi over 4. Because 5 pi over 4, yeah, it'd be negative pi over 4.
And not the log right.
I got this one right. I got that one wrong.
Yeah, that's what we
That was tricky. Elise, here's your,
Yeah.
I think everyone.
your original and then your graded ones underneath.
Well, it's fine.
You remember the domains now?
Yeah.
It was so much.
Yeah, it
I
was.
couldn't remember. And it
Yeah.
was hard.
I think that's just trying to explain it, but I can do it.
Versus, sure.
It is good, and
So he suggested that next time try to write darker so you get graded better.
Yes, I can name the square.
I'll have to scan it to him and then back so that you can read it.
Yeah, I'm not sure.
It's awesome.
Here you go, Dylan. This is your original and then the one you graded.
Number 1
Say
I still
doctor.
correspond to.
Yeah.
He's
Is he a doctor?
I don't know.
Assume he's a
I think so. I don't know that.
Around that.
Don't worry about it.
Sometimes it's a little bit.
It's the same thing.
It's pretty bad.
Yes.
Don't worry.
He might be ranked in the military. I don't know.
Well, you know what? That's what also, I can go to and this. been there, done that.
Yeah, I've written
I've been-
CPS
I've been
things in my life.
I've been a
Yeah.
grad student, I know.
Yeah.
Dale, you want me to hand off on the limit handout? Or hold
Not yet,
off on
just
it?
wait. Yeah, hold on.
Okay. Okay.
Thank you. It's time. So let me check roll real quick. Oh, so everyone is here. On time. So,
Math club has to start next Friday.
Yeah, we were gonna ask that too. No problem.
Expo and Junior.
Find out.
He wanted to study what he
You won. I feel like you don't lose any arguments.
I don't.
Okay. So, first I'm going to remind everyone, although here aren't here, but maybe you can share this here a little bit. And attendance counts today and being late today. I've already lost a few points. Next, you have your test back. Let's do the test score on the lawn. Everything's pretty close everywhere. It wasn't necessarily great. On the other hand, it wasn't unusual compared to past tests. So, what I'm going to do, if you have questions about your specific, hey, why did you take off points here? I don't understand how I do this problem, whatever. I'll be glad to talk with you, but I'm not going to take time during class to do that. So we'll do it outside of class. ICC students will just come see me. That would be DCC students are going to be home. So my phone number is on the syllabus. And call me. So now I'm talking to or Miss Tina and explain. I already heard her kind of talk about some stuff. And that's good. So she can explain a lot of those things too, I believe, for you if you have questions. Although I would say sometimes I can't even read my own handwriting, so I'm not sure if you can or if she can. I'll try to explain if you have questions. The third thing about the test is, since this was really a pre-calculus test and it's a first test for nearly everyone with me, so what do I expect? What's the test look like? How do I handle it? I don't want everyone to start off with really bad grades, so what we're going to do is I'll spread it up. What I'll do is I'll write up a nice neat solution sheet on the test. I'll post it on Moodle. I'll do that this 5 seconds. And then what you can do is and copy. How about that? Fairly easy extra credit. Okay? That'll be worth 10 points on
Dale,
your.
we're having trouble hearing you. The volume is kind of low. And they
I'm-
heard extra credit
and you-
and wanted to hear you.
And they got really excited, and then they have a little bit. What's the extra credit? The extra credit is you have to wash my truck every day for the next month.
Oh, he drives a truck.
So, the extra credit is I will post a solution sheet in Moodle sometime later today, and then by Tuesday you have to turn in a hand copy of that solution sheet, of the entire solution sheet, like meaning everything. Okay, we clear on that?
Is it,
You're not gonna on this test. You're not gonna sit down and make directions. You're just gonna copy the solution. Easy.
so, is it like reworking the whole test? For extra credit?
But yes, but you're just copying. You're not.
Oh, so we're literally just copying. Oh, okay.
Okay.
I'm gonna post the solution sheet, and you're going to copy.
I can deal with that.
You don't have to do it. If you don't want to, if you don't want to get writer's cramp, then don't. Just,
I'd rather get cramp in my hand.
yes, I will. When I post it, I will post in Moodle in the forum, which will automatically send you an email that's posted.
What does OPSH mean?
Oh, that'll be due on Tuesday. So I'll put that in the post as well, so that you'll know that it's due on Tuesday. Are we clear on that? Questions on the assignment?
What is it?
No
Well, if
questions.
you were
Good.
here 5 minutes ago, he explained it.
Emily and Grace will finally got here.
Okay.
This is really stupid.
Now, what about homework? We need to talk about last night's homework for a few minutes and then start on something new. So, Kyle looks like he has a hand up. Kyle, you have a question?
Yeah, not a specific one, more of like a general question. So yesterday, I thought I heard that we only had to explain if it was false. But when I was doing my, explain our answer, like the statement was false.
So if it's false, explain. Is that what you mean? That's what you're asking about?
Yeah, is that correct?
Okay.
Because I was doing the homework and I was like checking my answers, and some when it was true, it was explaining why it was true, but I didn't know we had to do that.
Well, like on number, for example, Joe was just asking about number 21 in the homework.
Yeah.
And the answer's true, and then there, because the directions say, determine whether each statement is true or false, and then justify your answers with reason. So, to me, that means either true or false has to be justified. Now, in my opinion, so normally you think of, well, I just get to say true, and if it's false, I have to explain. Well, that's not the way this is worded. Either one has to be justified. But in my opinion, their explanation provided for number 21 is a little bit, it didn't seem like much to me, and it seems kind of confusing. To me, the explanation for number 21 would be, if for all real numbers x, there's some real number y, if y equals x squared. And I would say that, yeah, pick any real number x in the world, I can easily find for you at least one y value that is the square of x. Sure. So that would be my kind of explanation. I might leave out the sure and that kind of stuff, but that would be my kind of simple explanation of what they thought. That makes sense, Kyle? Did I answer your question or not really?
Yes, sir. Yes, sir.
Okay.
Yeah.
Other questions you would like to talk about? So I want to compare 22 and 44. Just real quick. With your notes. So let's discuss this.
22, 44.
22 and 44 was the, no. On 22, it says, for all real numbers x, there's some real number y with x equal to y squared. What do you think about that? So 2042 looks like the same thing, doesn't it? I agree, it's false. All the numbers x, there's some real number y with x equal to y squared. Fine. Why do you say it's false? Because x equals -1, therefore y squared. Yes. Yes. The way the sentence is structured, it has to work for any x value that you can find the value that squares to make that x value. But that's not true. Example, so that's a good example. Negative 1 is a perfect example. I can't find a real number that I can square to make negative 1. That why I circled 44, I was thinking that there was something different about it. As I'm reading it, let's see, all real numbers x, there exists some y, such that x equals y squared. That's the same. Okay. So 44 and 22 are the same problem. We all see that those are the same problem? It's not the same way. We just know where it doesn't exist. The 22 says there is some real number, and 44 says there exists. Remember when we talked yesterday, there exists is kind of equivalent to for some. So 22 and 44 are identical problems in my mind. Then I circled 43 and 46 as something to kind of mention real quickly. There's a relationship there. So what about 43? All real numbers x, all real numbers x, there exists some y such that x is less than y. Davidson, someone at Davidson, what do y'all think? Is that true or false? Why? What do you think?
43. I want to say it is true, and for example, you can make y equal to x plus 1. So in every case, y would be greater than x.
Exactly. That's exactly the same type of problem we went over yesterday. What about 46? There exists a real number x such that all real numbers y is greater than x. Andy, what do you think? True. This real number x. All real numbers, y is greater than x. So what would that real number? This x that they're saying, if there's one, is the name the one that works? So they're saying, I can find some x out there in the world so that for every other real number I can think of, it's got to be bigger than that x. That's not true because if you pick y be negative 100 million, then x equals negative 200 million is smaller than it. Or wait, y is bigger. So I went wrong with that. You know what I mean? Y is bigger than x, so that I need to go with that. That's the sum of it. Okay, and finally, what about the proof? Did you? So 76 the proof. Did y'all get something for that? Yeah, I think you might have actually overcomplicated just a little bit. So it says even in an odd, I'm going to go to the left. Even in an odd, wait, odd, sum of an odd integer with another odd integer is even. So I think that's not exactly, so that's not very dark. Let me get another one. I'll be right back. Sum of two odd integers is even. I mean, we all know that, right? If you add 3 and 7, you get 10, which is even. If you add 15 and 25, you get 40, which is even. But how do we prove that? Let's let x be even. I mean, the odd from start with odd. But x be odd and y. So what does that mean about x? The definition of odd, what does it mean about x? A plus 1. So that this means x equals 2 times, I'll use m for lack of creativity, plus 1 for some integer m, comma, and what does it mean about y? If y is odd, what does it mean about it? Davidson, someone Davidson?
It's the same.
Emily, what do you think? Y is odd. What can you tell me about y?
That it would, then it would be the same as x, so it's 2m plus 1.
Yes, except we don't use the same m variable. We have to use a different one. Does that make sense? Did you say m, or did you say it should be like a different one? So y equals 2, say n plus 1. Or use, that sounds too similar. M and N sound alike, so I'm going to change my game plan. I'm going to make it P and Q. Or some integer Q. Now, why do I have to have 2 different integers allowed? Although P and Q could be the same number, literally the same number, why can I not use the same variable for my integer? X and Y could be different. If I say X and Y use the same variable for the integer, that means X and Y are already equal. I can't have that. They might be equal, but I don't know that. Y'all know the story about, so I use P and Q, so you've heard mine get P's and Q's. Have y'all heard that expression?
Yeah. What do you say?
Mind your P's and
Those
Q's.
are mind your P's and Q's. That's it. Okay, it's going back way back in the old days when Noah came over on the ark. Y'all know the background of where that came from. P's and Q's. Mind your P's and Q's. I think it's fascinating. So you've heard Mark Twain. He worked in a print shop. Now, print shops in the old days weren't like computer printers and stuff. So you took typeset, you took little letters, and you put them in a big machine where you laid them all out in rows, and then you press the paper in. That's how it worked back in the old days. So think about a lowercase p and a lowercase q. They're really just mirror images of each other. And so when you take them off this press, you got to put them back in the drawer. If you're not careful, you're actually going to put the q's and p's. Now when you typeset, you got all that stuff. So you got to mind your q's. Look at that. I go off on tangents every once in a while.
Tough room.
Okay, that is tough room. I got it. Okay, so now what? All I've done is I established my hypothesis. Once again, all this is just taking care of the fact of a hypothesis of 2 odd integers. Now I've used definitions for this hypothesis to get something. Now what do I got to do? What's my objective? What's my conclusion? X plus y, the sum, X plus y has to be equal. Well, let's show that it is. This gives X plus y, which is the sum. Now we're trying to get to the conclusion. I'll be right back with my marker. My conclusion is even, so the sum is even. So we're trying to show that the sum is even. So that now we're working on our conclusion. This gives X plus y equals 2p plus 1 plus 2q plus 1. That still doesn't do it, folks. What does it mean to be even? What's the definition of even? How about Dylan? What's the definition of even?
Plus 1, 2.
No, Multiple
Here.
2.
Has to be multiple of 2. So in order to show that this is even, I got to show it's a multiple of 2. Can you do that from here? Really easy now. So if I combine my terms, if you will, I got a 2p plus 2q plus 1 plus 1 makes 2. If I factor the 2 out of the p and q, then I've got 2. And then I can factor a 2 out of that 2 right there. So I got p plus q plus 1. My closure plus q plus 1 is an integer. So the sum is something like that. Anybody get that worked out? I didn't really that much. But you saw what you had to do with the 2p plus 1 and the 2q plus 1. Good.
I use the X to Y thing. I just use different.
That's fine. Yeah. The actual variable used doesn't matter to me. The key is showing this process right. That's, if you had to focus on one key issue, this is it right here. That's how you show the sum is even. Okay. We're good with last night's homework then. Okay. Well, if we're good with it, then I'm going to say we're done with it. And we now have pre-calculus all about acquiring the tools needed to build the skyscraper of calculus. So you supposed to have this set of tools now. And that was your pre-calculus, elementary. Now we want to start building this calculus skyscraper. In the book talks about laying a foundation. So as a foundation, I'm going to give you a little bit of history again. Where's the start of this? Pan out now. Okay, so the first thing is, I don't know the dates memorized. I looked this up. And, isn't Google wonderful? It's just like, I don't have to go to the library and go to card and stuff. So a Greek philosopher who was actually a teacher of Plato and Aristotle and Socrates. You've heard of those guys, right? Well, there's another dude named Zeno, Z-E-N-O, Zeno. He was around in the 400s BC, so prior to Plato. And Zeno proposed a paradox. And this paradox led to a certain type of thinking that began the development of calculus way back 400 BC. Paradox was he's watching the king's archers shoot their arrows. They go, okay, but now his question was, well, wait a minute. Here's the paradox. I know that at some point in time, the arrow has gone halfway to the target. At another point in time, the arrow has gone halfway up the remaining distance to the target. At another point in time, the arrow has gone halfway to the target again, and so on. So if the arrow is always going halfway more to the target, does it ever get to the target? It's like a paradox to me. We know it is the target. But think about that. This idea is I'm getting infinitely close to this target without actually ever hitting it. You understand? Half of half of half. You're getting closer and closer and closer without ever actually hitting it. That's kind of, what do I do with that? So, it turns out that we're talking about a sequence. We studied sequences a little bit in pre-calculus. So, we're talking about, he went half the distance, and then he went half of that distance again. So what's half of half? So he went a fourth of the way to the target. And then the next time he went half of half again. So what? All right, he went an eighth of the way to the target. And then he did half of that, which is a 16, and so on. So the first observation, this is where the paradox lies. Does this ever get to a total? I mean, do you ever get 0 so that I'm on the target? Does this number, this pattern, does it ever hit 0 so that I'm on the target? No. But, in some sense, as pattern continues, the limit is close to 0, but not 0. And whatever close means, we'll have to get back to that later. So it's like the arrow never quite reaches there, but then we can show with series, so that's sequences. Now, also in pre-calculus, we studied series a little bit. So a series is adding up. So if I add these first two terms together, what's his total distance if you add these two terms in? 3/4. Now, what if you add that and plus the next part of the process? If you add those together, how far do you get? So 3/4 plus 1/8, 7/8. Okay, well, now let's add the next one in. So we're going to take 7/8 of the distance, and we're going to add in another 16. How far towards the target has he gone now? 15/16. Okay, now look at this pattern. What do you observe there? This is getting closer to 1, meaning the entire distance gets covered. If you add up all those little pieces, this pattern is getting close to 1, the entire distance. That's kind of interesting for that far back, that kind of a thinking process, that kind of a paradox to wrap your mind around it. We don't have computers or anything to deal with, but just to think about that, this idea of getting close to 0 in the little sub-distances, and if I add all the distances together, and in fact in series, we can prove that this actually is 1. It looks like it's getting close to it, but we can prove it actually is. In Calc 2, we'll come back to that and actually show that. Okay, that was Zeno back in the 400s BC. Then along came Galileo in 1500s AD. You all familiar with Galileo, right? You know what he did? He did a telescope. He also did something else. Newton gets credit, supposedly, for inventing gravity. What's the story? Everyone's heard the story. Like he's sitting underneath the apple tree, and the apple falls on his head. He's like, "Oh, gravity." You know what? Galileo figured out gravity before. So I'm gonna. Oh, Galileo. He got on the Tower of Pisa. You know what the Tower of Pisa is?
Yes.
The one that, so my Tower of Pisa is too tall. So he got a leaning Tower of Pisa because with the leaning Tower of Pisa, it leans out at like 20 degrees. So he can now lean out and drop objects. And he got up there and he's like, let's see what happens. He's like, I got a bowling ball and a small rock. And he drops them. They hit at the same time. It's like, what the heck? That bowling ball weighs a lot more than the small rock. He has discovered the concept of gravity. And then he performed an experiment. The experiment was he took an inclined plane with a ball on it, and he measured the distance it traveled in, say, 1 second, and then measured the distance it traveled in 2 seconds. And he discovered that no matter what size ball he put on there, the distance traveled in 2 seconds was 4 times as far as the distance traveled in 1 second. Okay? Galileo discovers gravity, and he discovers that at 1 second you get a certain amount of distance, and in 2 seconds you get 4 times the distance. And he made a bigger ramp and went to 3 seconds, and he found out it was 9 times the distance. Do you see a pattern evolving here?
Mm-hmm. I do.
Not 2 times the square. It's the square. The distance varies directly as the square of the distance. That's what he's done. So, distance varies directly as square of time. In pre-calculus, you learned about varies directly. So, here we are again. I'm helping you dig out a good foundation area so we can go and start pouring the concrete and building our skyscraper. So this is a history lesson to get you started. So varies directly as the square of time. So that means from pre-calculus that the distance is equal to some coefficient times time. There. It turns out that this coefficient is related to gravity. It's not actually gravity; is actually half of gravity. So it's 1/2 of 32 times time squared, and that 32 gravity acceleration is approximately, and it actually varies depending on where you are on the Earth and all kinds of things, but approximately round figures, on average, is about 32 feet per second squared, or that's equivalent to 9.8 meters per second squared. And so that's the gravitational acceleration that you see right here. And then there's this 1/2. We'll get later in calculus here. We'll understand more why there's a 1/2 there. But for now, this is my K. Is this number here? This 16 is K. So that leads me to another thing that we can talk about that's related to what we're dealing with here. I'll come back up here. So with Galileo and his discovery, we now model with an algebra equation, a fairly simple algebra equation, the height of his bowling ball when he drops it from the Tower of Pisa. So the height at time t is basically the starting height minus the distance traveled. Are y'all with me here? So we'll pretend that the starting height of the Tower of Pisa, and I'm making up a number, but it's not that far off, is 100 feet. And so the height of the ball is now 100 feet starting minus the distance traveled, which is 16 t squared. Do you follow that? So the distance traveled is always proportional to the square of time, following under gravity. So the height, not distance, the height above ground is starting height minus the distance traveled. Does that make sense? Okay. So my question is, this is now a pre-calculus question. What time does the ball hit gravity, the bowling ball? quick solve that problem. Okay. Person raise your hand with the correct answer. It's 2 brownie points.
It's 2-1.
Brownie points.
Question is one more time. I'm not answering it yet. When number of seconds does all get from? That's the first question I asked. That's a pre-calculus question. We will do that. Probably easy. Jacob's had his hand up. What do you got, Jacob? Yes. The time is 2.5 seconds. I agree with that. How did you determine that, Jacob?
You said it's when it hits the ground, so the hot will be 0. So I just said set that equal to 0, and I just solved it.
So if it hits the ground, then the height above ground better be 0. And so we just set our equation equal to 0. And so that means t squared is equal to 100 over 16, which is divided by 4 is 25 over 4. And so t is equal to the square root of 25 over 4, which is 5 over 2, which is, as Jacob said, 2.5. Okay, so 2.5 seconds for the ball to hit ground. Good. Now here's another thing that's more calculus. My question is, how can we figure out how fast that ball is going when it hits ground? And it's going to kind of go back to the concepts of short and long Zeno's lines. Let me give you a hint. So my objective now is, as an introduction and digging a nice big foundation, what speed is the ball at impact? Now, some people are going to be real smart aleck and say, well, it's 0 because it's impact to the ground. Okay. What I mean is, at 1/2 or 1/1000th of 1 nanosecond before it hits ground, how fast is it going? So, not after it's come to rest, just as it's impact to the ground. What is its speed? How can I figure that out? Well, here's your hint. What is the average rate of change on time 0, 2.5?
That's cool.
You can figure that out with them. Come on. Just have a test on this.
It's ground at 2.5 started.
Be in 2.5 seconds. So it's not 100. The answer is not 100. What is the answer? I'm glad this isn't Final Jeopardy because y'all just lost.
Say that.
How do you find average rate of change? Right, so how do you find average rate of change?
F of B minus F of A over B minus A.
Okay, so we're going to do h of 2.5 minus h of 0 over 2.5 minus 0. Good. What is h of 2.5? 0. We just figured that out over here, folks. What is h of 0? Well, it better be 100 because that's where we started. Okay, yep. And this is 2.5. So it's negative 100 over 2.5. So divide that from there. Negative what? negative 40 feet per second. So 32 was a good guess, but it wasn't really quite accurate. So my question is that how fast the bowling ball is going when it hits the ground?
So that's the average speed.
No, it's going faster. That's absolutely right. So if I go back and graph this function as a function of time, this is h of t, and this is 100 feet, and this is 2.5 seconds, then my graph is a parabola. Looks like that. And what we just calculated, this number right here, is simply the slope of, so slope equals negative 40. So clearly, just like was all saying, actually, Garrison Keillor. Anybody ever heard of Garrison Keillor?
Ferris Bueller?
Heard of Garrison Keillor? Anybody else heard of Garrison Keillor?
What's he saying?
Fairly famous dude. Yeah, maybe. Maybe sometime listen to NPR, whatever that is. So he has a storytelling time, and he tells stories on National Public Radio, and it's kind of an ongoing tale of a made-up town called Lake Wobegon. And he always signs off with, and that's the news from Lake Wobegon. Where all the women are strong, all the men are good-looking, and all the children are above average. Think about that last bit. All the children are above average. Is that possible? No, that's not how averages work. So clearly, this being an average slope, the speed of this ball is not always going that. In fact, right here, because it's flat, the speed is 0. And right here, the steepness of that is a lot more than 40, so it's got to be going faster, as Joseph said. So how can I figure out the speed there? Any ideas?
Okay.
No suggestions.
Have to find a curvy slope.
Excellent suggestion. What if we made a table?
Oh.
Let's say this x value is going to be we're going to consider the interval from, we'll call it A to 2.5. And Joseph said, well, what if we looked at the average rate of change at a smaller interval? Excellent suggestion, because if I get a smaller interval, then the slope of that smaller line is going to be much closer to the slope of that curve. Excellent suggestion. So A is going to be my input. That's the start. That's going to be, I'm going to have A values right here. So I'm going to have an interval that's not at 0. And I'm going to vary my A values, making them closer and closer. And then I want to find the rate of change. So we just, for example, we started with A is 0. That was our starting interval. A is 0. And we found a rate of negative 40. So now what I'm going to do is I'm going to suggest, why don't you do a rate at 1? Okay, real quickly, calculate the rate from 1 to 2.5. On your paper, write it on your table, and then tell me. I'm not going to do this. I don't know how to do it. Is everyone with me on what your assignment is? I need to see like pencils writing on paper. Staring at me is not going to answer the question.
What's 100 minus 16?
let's say 45 or 56. Okay, so I get a negative 56 feet per second average. That's average. If I shrink my interval down to 1, so what I did there was I now have an A of 1, which is like right there, then 1. So I took this line. That line is steeper. How about that? So it's closer to the actual answer. Can we get better? Sure. Let's make another interval. How about let's try instead of 1, let's jump all the way up. Let's go crazy. Let's jump all the way up to 2. I'm not going to write it next. Y'all need to feel. Y'all need to be able to do this yourself now. Type of thinking will come back maybe a few hundred times this semester, so we need to be getting on top of this. Carson, do you have an answer for 1? Excuse me, 2. 2. Where did it? Carson?
Yeah, what?
You have an answer for us for 2?
Yeah.
Yeah.
72. Well, negative. If you want to think that.
Negative 72 feet per second. I'll go with that. Anybody second that number? Okay, good. Oh, man, I'm still not really clear on how steep that is. Because really the interval is still, I mean, I went all the way down to 2, but that's still a pretty good gap. Now it's really aggressive. How about let's do 2.4. This is when you're allowed to use your calculator, of course. You got an answer for 2.4 yet? By now you probably got the plan down. You can do it pretty quickly. Basically, it's just a 0 on the first term. So whatever you get when you plug in 2.4 here, divided by the difference, which is going to be 0.1. H of 2.4 divided by 0.1. That seems to be the fight. What'd you get? Make a number? Negative 78.4. Okay, I'm getting a little better feel about it. Let's try another one. How about 2.49? H of 2.49, height of 2.49 divided by the difference in time, which is only 0.01. So we're making a really small interval now. This was Joseph's suggestion. Good suggestion. What did you get, Mike? 149? That sounds hot. That sounds better. Negative 79.84. It looks to me like every time I shorten my interval, and my interval was pretty long here, and then every time I shorten my interval, getting closer and closer to the end time, 2.5, my speed keeps going up. But it's not going up as much now. Y'all see this? It's like, oh, I jumped up by 16. Then I only jumped up by, 16 again. And then I only jumped up by 6.4, and now I only jumped up by 1.4. Let's do one more and see if we can prognosticate what the answer is. How about 2.499? Try it out. Okay, I'm going to agree with that. That sounds reasonable to me. So this time, we shorten the interval again. Relatively, the shortening from here to here is actually a relatively big amount of shortening. Compared to the overall, it's not, but in between these two, it's a pretty significant shortening of the interval. But the speed only went up 0.14. So can you, from this pattern, like with Zeno, can you say, what does the pattern seem, as I keep shortening this interval, what pattern of speed do you seem to be getting close to? Looks like to me this is getting close. It's close. Negative 80.
I can't see the right end of the chart.
I'm sorry, what now?
We couldn't see the right side of the chart. There we go. Thank you.
Yes, thank you. Well, does that make sense to everyone? Okay. And there's one last bit of foundation to a little bit of history. So that's two big pieces. Zeno kind of got us started way back. Galileo did some significant work with gravity, and then Newton, of course, took off with it. But in between Newton and Galileo was another gentleman that helped out. And that is because all along, before Galileo, with Galileo, there was a disconnect. The Arab world had developed algebra. In fact, algebra is an Arabic word, and it means, I believe it has to do with variable. But I'm not, don't quote me. And then, parallel to that, and in the same time frame, maybe a little bit earlier actually, the Greeks were developing geometry. So you had two separate worlds. The Greek world and the Arab world, those don't really get along in the first place. So we just kind of went along. We had algebra. Galileo was using algebra, but he didn't have a pretty graph. He didn't have it. Just algebra. It took a guy named Rene Descartes. You heard of Descartes? Yeah. I remember talking about Descartes one time, and a humanities professor walks by and says, steps in, what are you doing talking about Descartes in a math class? Descartes' actually a philosopher. In fact, back in those days, mathematicians, philosophers, a lot of times were one and the same. He's famous in philosophy for saying, cogito ergo sum. Well, that means, cogito means I think, ergo means therefore, and sum means to exist. So I am, I think, therefore I am. So that's what he was famous for saying. But as a philosopher mathematician, mathematicians and philosophers are actually fairly notoriously lazy. So one day he's laying in his bed, literally laying in his bed, looking up at the ceiling, and he's like, there's a fly walking around the ceiling. And he wants to be able to tell his assistant who's outside the room where the fly is without having that assistant to actually come in and see it. He reads this, he's sitting there thinking, he's like, how can I describe the algebra function on a graph? And so he's like thinking about this, he's staring up at the ceiling, he sees this fly walking around, and also an insight. Oh, all I gotta do is tell the assistant, come in the door, you walk 10 feet from the east-west wall, and then walk 3 feet from the north-south wall, look straight up, and there will be the fly. And that idea, based on this fly, literally gave us the Cartesian coordinates. So it wasn't until he came along and got us the Cartesian coordinates that we could tie the algebra with the graph. And then we can have Newton come along and put all that together and say, oh, let's make the calculus. So now we're ready to start some, actually pouring some concrete. So now you can, Ms. Cleaner, you can hand out that limit sheet that we. Well, I'm going to hand out in here a a sheet that I want you to work on here in class. This is on what's called limits. And that's what we've been exploring. We just looked at the limit of the rates of change. And we looked at the limits of the arrow. So this is a little bit of kind of an introductory lab, if you will, on limits. And so working together, start with, see if you can fill in the first page. Do it, and then see if you can fill in the blanks.
Say right now to do it.
Now we're going to find it.
I don't really even know how it works, but.
When you finish the front page, just pause for a moment so we can discuss it for a moment.
Do you have a calculator?
I did, but I gave that around like a
Just fine.
Just a couple of
That's what's going to happen. But if they have to upload the massive PDF to be empty. They have like a Word document, they're doing, and or if they email you, they can email you.
Everyone get this first few questions on front page. A minute or two, maybe.
Just wants to get back in.
So let's just, honestly don't have the answers, so I'm gonna ask you the answers. How about, can't hear, I gotta go back, that's a dead zone up there. It's dead zone, it's too close to Jacob. How about, Sammy, would you read your output values for x getting close to 2 from the left. What were your 4 output values?
I got 4, 4.8, 4.98, and 4.998.
Everyone agree with that? Okay. How about, who else? Who else? Josh, did you read yours from the right? Output value.
Okay, so starting with 2.001, I got 5.002, then 5.02, 5.2, and then 6.
Okay, everyone agree with that? Good. Okay. How about Justin on the first answer below that, which says as x approaches 2 from the left, what would you say it appears as you come from the left? What values did we see happen very close to? Got close to 5. Okay. And so you should have a 5 in that blank, and at the end of the row, have a 5 there also. And the way you read that symbol at the end of that row, you read that as the limit of 2x plus 1 as x approaches 2 from the left. See that minus sign next to that 2? If you have a minus sign on the right side of a number, it means from the left. It doesn't mean the number is negative. And so that answer should be 5. I agree. Okay. How about Chloe? What did you get from the second answer below there?
I got that as x approaches 2 from the right, f of x gets close to 5.
Good. So read that last bit for us too.
We write this as the limit of 2x plus 1 as x approaches 2 from the right equals 5.
Good. That's exactly how you read it. Excellent. And then finally, the last statement says, as x approaches 2, f of x in general. So now we're talking in general. There's kind of 2 ways to think about limits when you're talking about a function graph like this, or a function formula. Coming from the left, coming from the right, and then if both of those meet in the middle, if it's like your fingers meet in the middle, then the general limit is said to be that same value. So f of x, the general limit gets close to 5 as well, that last thing. The note at the bottom says, if, like I just said, if your fingers don't meet, then the limit doesn't exist. So now we have your homework would be to finish the problems on the back side. So finish problems on the back side. The directions are make a table and use the process we just described to determine the limit of f of x as x approaches 4 on these following functions. Comment on number 3. As you use the table in your calculator on number 3, what is one important thing you need to remember? Any thoughts?
To switch the calculator mode to degrees?
Actually, the opposite.
Okay.
In radians. So as a or not a mnemonic, but just as a reminder, remind yourself now that you're in calculus, radians are real. You need radians. So sometimes problems will be given in degrees, and you need to convert from degrees to radians. So anything in calculus generally is going to be radians. Okay. I guess that's it. Also, go ahead and read through section 1.1 of the homework in the textbook, and do problem 1 so we can discuss it on Tuesday when we come back. And there's other homework already on Moodle that you can start on if you want, but I'm just going to say you can just do problem 1 if you want. But if you have a long weekend, I would get ahead of it with me because you don't want it to pile up on you. So I'm going to encourage you to do the homework on section 1.1, but you don't have to. You do need to finish the lab, do problem 1, and I will post the solution sheet so you can do that as well. Y'all have a good weekend. Be safe out there.
Before we get out of here, 1 second. Gonna hold you hostage.
Sorry, that's just my dean. She's got to talk to. She's got to
They
talk to
aligned?
the students about peer tutoring.
Oh, okay, fantastic. So we're done. You're done with us.
Yes.
Over and out.
Have a good weekend.
All right, so I am looking for students who are interested in